Good day everyone, our topic for today is all about kurtosis. But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. Also, you will find different subjects in this YouTube channel, just select the playlist section. And now let's proceed to our main topic for today, which is all about kurtosis. What is kurtosis? It's another measure that tells about the distribution. The distribution is said to be normal when the value of kurtosis is equal to 0.265 or mesokurtic. When its value is less than 0.265, it is leptokurtic. When the distribution is subnormal and when it is greater than 0.265, it is platykurtic or abnormal distribution. So the general forms of kurtosis, we have leptokurtic, mesokurtic, and platykurtic. The formula for the kurtosis is Ku equals Q over P90 minus P10, the percentile and the quartile. So where Ku is kurtosis, Q is the quartile deviation, P90 is percentile 90, and P10 is percentile 10. The requirements are the following. For the QK, we have lower boundary plus K over 4 times N minus cumulative frequency or CF over Fm, frequency mode times I. For the QK, we have is equal to Q3. And then QK is equal to Q1. And then for the Q, we have Q3 minus Q1 over 2. So in short, we need to solve first the quartile 3 and quartile 1 so that we can get the quartile deviation with the formula Q3 minus Q1 over 2. For the PK, percentile lower boundary plus quantity K divide 100 times 3 N minus CF over Fm times I, wherein the PK is equal to P times 10 and P90. So these are the following requirements that we need in order for us to solve the kurtosis. So let's start with the Q1 and Q3. Find the kurtosis of the given data below. So we have 61 to 65, 56 to 60, up to 41 to 45 with the following frequency: 4, 11, 10, 12, and 3. First, arrange them in a vertical form. The highest should be at the top, so 61 to 65, and the lowest should be at the bottom, so 41 to 45. The frequency for 11, 10, 12, 3 are also arranged in a vertical form. First, get the class interval. So the answer is 5. How? That is 61, 62, 63, 64, 65. So there is an interval of 5. 56 to 60, 51 to 55, and up to 41 to 45, there is an interval of 5. Next is the frequency. For the frequency, we have equals to 40. 4 plus 11 plus 10 plus 12 plus 3 is equal to 40. The next one is the class mark or X. What is class mark? That is the middle of the interval or each interval. So we have 61 to 65. The middle number is 63. 56 to 60 is 58. 51 to 55, 53. 46 to 50, 48. 41 to 45, 43. Then get the total and we will name it as summation of X, which is 265. Next, we have fx, which means multiply the frequency and the x. So 4 times 63, we have 252, 11 times 58, 638, 10 times 53, 530, 12 times 48, 576, 3 times 43, 129. Get the total of summation of x, or get the summation of x, so you will get 2,125. Lower boundary. The lower boundary will be, the 61 will be subtracted to 0.5. So 61 minus 0.5 is 60.5. 56 minus 0.5, 55.5. 51 minus 0.5, 50.5. 46 minus 0.5, 45.5. And 41 minus 0.5 is 40.5. And finally, for the cumulative frequency, we will get the frequency, of course. Kaya nga tinawag na cumulative frequency. It is less than cumulative frequency, so we will start with the lowest score. What is the lowest? 41 to 45. Not 3, ah. It's 41 to 45. So, we will start with 41 to 45, and we will just write 3 here. And then, 3 plus 12 is 15. 15 plus 10 is 25. 25 plus 11 is 36. And 36 plus 4 is 40. Okay? So these are the following requirements we need in order to solve the quartile 3, quartile 1, and the quartile deviation. Alright. For the quartile, we have this formula. First, we need to solve k over 4 times n for the quartile 1. So we will solve the quartile 1. We will first solve the quartile 3. Sorry, I'm wrong. So, we have 3 for the k. That's qk. So, k is 3. And then 4. N is 40 as our given a while ago in the table. So, 3 times 40 is 120 divided by 4. The answer is 30. So, this 30 is our basis for our cumulative frequency. So, what is the number which is equal to 30 or greater than 30 but not less than 30? Which among the cumulative frequency is greater than 30, equal to 30, but not less than 30? And that is 36. 25 is not greater than 30. It's neither also equal to 30. It is lower than 30. So 36 is the answer. So we will encircle all the numbers under 36. Okay? What is less than 36? That is what we call the less than cumulative frequency, which is 25. Okay. So this is greater than or equal to 30. That's 36. And less than 36 is 25. So this is our formula. Our lower boundary now, we will get it into the encircle row. So we have 55.5. K over 4 times n is 30, right? Minus less than CF, that is 25. The FM is 11. And the I is 5. Now we had already the given. So we can now solve. So this is 55.5 plus 30 minus 25 over 11 times 5. And you will get 57.87. Round off your answer to nearest hundreds. Okay? Now, let's proceed to the next one. The Q1. So we're done with the Q3, right? So we are now in Q1. Again, in Q1, we have 1 over 4 times 40. 1 for the K, right? Because we have a formula K over 4 times N. Our N is 40. Our K becomes 1. Kanina 3, now 1 because we are in Q1. And K is equal to 1. So 1 times 40 is 40 times divide 4, the answer is 10. So we will look for a number that is greater than 10 but not less than 10, and that is 15. Okay? So we will encircle all the numbers under that 15. And what is less than 15? That's 3. So for our formula, we have QK. What is our lower boundary? That is 45.5. K over 4 times N, that's 10. Minus CF, that's 3. FM is 12. And I is equal to 5. So that is our, okay, this is now our given. We write them in the formula. So we have 45.5 plus 10 minus 3 over 12 times 5. And, okay, 10 minus 3 is 7 divided 12 times 5 plus 45.5. Okay, you will get 48.42. I repeat, 10 minus 3 is 7 divided by 12. Your answer will be multiplied to 5 and then add your answer to 45.5. You will get 48.42. Round off your answer to nearest hundreds. So we're done with Q3 and Q1. We can now solve the quartile deviation. So this is Q3 and this is our answer for Q1. For the quartile deviation or Q, we have a formula Q3 minus Q1 divided by 2. And we have 57.87 minus 48.42 and you will divided by 2 and you will get Q equals 4.73. So we're done with Q. Now let's proceed with P or the percentile. For the percentile, we will use the same table that we had solved a while ago. And then, for the percentile or PK10, the first part is P10, the second is P90, right? So P10, our K is 10. The formula for that is K over 100 times N. Our N is 40. And then 100 is constant. So 40 times 10 is 400 divided 100 is 4. What is the number that is greater than 4 but not less than 4? In the cumulative frequency, we have 15. So we will encircle that. What is lower than 15 is 3. Using this formula, lower boundary, so we have the lower boundary, 45.5. The K over 100 times N is 4, minus CF, less than CF is 3, FM is 12, and the I is 5. So this is now our solution. So 4 minus 1 is, 4 minus 3 is 1 divided by 12. Multiply your answer to 5 and add to 45.5 and you will get 45.92. That is for the P10. Now, how about for P90? For the P90, we have K equals 90 times 40 divided 100, you will get 36. And it is exactly 36. So there is a 36 here for the cumulative frequency, so we can encircle that. Lower than 36 is 25. The formula is lower boundary. So the lower boundary is 55.5 plus K over 100 times N is 36 minus CF is 25 divide FM is 11 times I. That's 5. So this is now our solution. So 36 minus 25 is 11 divide 11, 1 plus 5. 1 times 5 is 5 plus 55.5. The answer is 60.5 or 50. They are just the same. Okay, so P90 is 60.5 or 60.50. So we're done with P90 and P10. And the quartile is 4.73. This is what we had solved a while ago. And then the Kurtosis formula is equal to Q over P90 minus P10. So our given Q is 4.73 over P10. P90 is 60.50 and P10 is 45.92. Subtract the 2 in the denominator and then divide it from 4.73 and you will get 0.32 as our Kurtosis value. So, since the computed value is 0.32, which is greater than 0.265, as mentioned in the definition of Kurtosis, the distribution is abnormal. Then, it is what we call the platyquartic. Okay? So, that's all about for Kurtosis. Ladies and gentlemen, thank you very much for listening and good day.